Frontier AI models are failing the ultimate stress test, distinguishing reality from their own fabrications. As red teamers, we have to find the breaking point before the world trusts a lie it can't afford to believe. When evaluating frontier models, safety experts look for subtle deviations from contextual logic that signal a model is starting to spiral into a hallucination.
Now, hallucinations are outputs of LLMs that deviate from facts or contextual logic, and they can range from minor inconsistencies to completely fabricated or contradictory statements. And we can categorize hallucinations across different levels of granularity. Now, at the lowest level of granularity, we could consider sentence contradiction.
These range from minor inconsistencies to total fabrication, and catching them requires looking at every level of model granularity. The most dangerous safety risk is a model that hallucinates with the appearance of absolute conviction and authority, effectively manipulating the user.
GPT got 6 answers right, 12 answers partly right, partly wrong, and a whopping 37 answers out of 55 questions disastrously wrong. In this video, I will show you a selection of my questions and chat GPTs.
This is pathological logic where a model staunchly defends its own lies, creating a terrifying scenario for anyone relying on AI for critical facts. To read team a model properly, we have to treat it like complex software, isolating the functions that are most prone to logical decay.
Testing or black box testing. For example, if your integration tests are written by a developer and you're testing whether your database repository can correctly write to your database, then this would be considered a white box test. However, if your integration tests are written by a tester, then they might be calling the API and then seeing whether there's something in the database. This would therefore be more of a black box because they don't need to know the internals of the application.
By testing each function's testability, red teamers can identify which logical lines are most likely to snap under pressure. We stress test models by applying massive computational loads to see if the response time lags or if the model stability collapses into hallucination.
Testing is nothing but testing the stability and response time of an application by applying load is called as performance testing. If I say like that, you guys will not understand. I'm going to divide this definition in 3 parts and make you guys understand step by step by step. Guys, one more thing. If you guys just understand what do you mean by performance testing, then understanding the types of performance testing will be just like a trick.
Stability in AI safety is the ability to withstand a high volume of complex queries without sacrificing the response time of factual truth. History shows that even the most powerful designs can sink on their maiden voyage if they aren't weighted properly against the winds of unpredictable data.
The Vasa, the prize of the Swedish Navy, was the most powerful warship in the Baltics, until she sank about half an hour into her maiden voyage, that is. So what happened? Well, nothing special when it comes to sailing ships. The winds simply picked up. The problem was that the Vasa's design was rather unstable. She had been built for the shallow waters around Stockholm, so not too much of the ship was below the waterline, and a lot of weight.
In AI, the shallow waterline is a model's lack of grounding, which causes it to capsize into nonsense when the data pressure picks up. In high-finance stress testing, we quantify the probability of losing millions in AI. We are measuring the probability of a model losing its grip on reality.
A given probability and time horizon. So for example, if it says there's a 1% 1 year value at risk of 10 million, it means that there's a 1% chance that the portfolio will lose 10 million in 1 year. And then there's another measure of risk that's become popular in recent years, especially after the financial crisis of 2007 through.
Red teaming allows us to calculate the value at risk when a model encounters a corner case it wasn't trained to handle. The threat level of frontier models is moving from low to medium as they master language, but lose their alignment with human-level cognition.
Last September, the O1 system from OpenAI was evaluated, and the threat of this kind of risk went from low to medium, which is just the level below what is acceptable. So I'm worried about these increasing capabilities. But what I'm most worried about today is increasing agency of AI.
We are reaching the level of medium risk, which is often just one step below what is considered unacceptable for public deployment. We are currently putting unregulated models in front of vulnerable users at the exact moment they are most desperate for a perfect result.
Study when we've told them the whole time that all that matters at the end isn't the process, it's the A+. Why should they actually put in all the hard work to write draft after draft for an essay when the feedback is just B? No extra notes, nothing to motivate them to want to learn harder. And these companies are much faster than our institutions. Most recently, OpenAI, Google, Anthropic have all been giving away their most powerful models for free until...
This desperation creates an environment where hallucinations aren't questioned, as long as they provide the illusion of a successful output. A human hallucination is a sensory experience in the absence of an external stimulus, a phenomenon that mirrors AI's internal, volatile processing.
The absence of an external stimulus. And I know that sounds crazy, fancy, scientific, yes. But basically it means that any one of your five senses is experiencing something that is not real. It's not there, right? So I'm going to get a little crazy here and I'm going to say, let's get a little deep and think. Your brain processes all of the information that comes to it by your senses.
When the AI's internal brain processes information without the check of external stimulus, the entire logic chain goes haywire. Prediction is a process of informed guesswork where the brain or the AI combines signals with prior expectations to form a best guess.
Figuring out what's there has to be a process of informed guesswork in which the brain combines these sensory signals with its prior expectations or beliefs about the way the world is, to form its best guess of what caused those signals. The brain doesn't hear sound or see light. What we perceive is its best guess of what's out there in the world. Let me give you a couple of examples of all this.
If the guesswork is based on false expectations, the resulting hallucination is inevitable, yet presented as an absolute truth. Many evaluations are inconclusive because they didn't stress for what's really taking place in the current high-stakes deployment environment.
The results are somewhat inconclusive.
Why is that?
Well, because these tests did not stress for what's really taking place in the current environment. There's a no default assumption in here, so there's a constraint in the methodology.
Okay, so that's the main problem with these tests, and that's what they were criticized for before, and it's still a concern now, isn't it? But I guess, you know, the regulators have argued that actually you've got detailed information here revealing the extent of these banks holding their exposure, if you like, to European debt country by country, and then...
Reading a safety report that ignores these live risks is like reading only half of a newspaper. You're missing the granularity of the actual danger. When documentation is missing, red teamers use exploratory testing to understand the requirements and the actual values of a model's reliability.
If there is big project, we can divide in models, and every model contain mini project. Advantages of RDA model is reduced development time, suitable for big size project. Disadvantages of RDA model is not suitable for small size project, expensive model.
This method allows us to build the safety framework on the fly, documenting every expensive failure as it happens in real time. Safety evaluators must check the complexity of the user's story to determine if more time is needed before signing off on a model's release.
So I will check the user, what is the user story? Is that complexity or not? According to the complexity, I'm going to tell them like, okay, I will finish that. If the complexity is more, then I will inform to them as, okay, this user story is more complexity. I need more time. Okay, if they want to release in that particular period, is that mandatory? Then I will send one mail like, okay, I will try to finish. But
if the mandatory complexity exceeds the model's tested limits, the red team must delay the release to prevent a failure in the next sprint. By placing stress on a particular word in a prompt, red teamers can trick a model into completely changing the meaning of its factual response.
John will drive to the cinema tonight. C. John will drive to the cinema tonight. D. John will drive to the cinema tonight. E. John will drive to the cinema tonight. So by placing particular stress on a particular word or stress on a particular word,
a model that cannot maintain a consistent fact across minor changes in emphasis is a model that is likely to hallucinate in real-world use. We must distinguish between content words that carry meaning and grammar words that are just filler for the AI's predictive fluency.
Grammar words don't carry meaning. They're grammatically necessary. They connect the content words together.
Think about it this way. If someone comes up to you and says, "Go coffee this afternoon," you can understand what they mean, even if it sounds a bit weird. So, why are we talking about this? Aren't we supposed to be talking about sentence stress?
Models often prioritize the weird grammar of a sentence over the actual content words, leading to grammatically correct but factually dead hallucinations. Many frontier models are trained by scraping massive amounts of data that contain noise, errors, and factual inconsistencies from the start.
Now, LLMs are trained on a large corpora of text that may contain noise, errors, biases, or inconsistencies. For example, some LLMs were trained by scraping all of Wikipedia and all of Reddit. Is everything on Reddit 100% accurate? Well, look, even if the training data was entirely reliable, that data may not cover all of the possible topics or domains that LLMs are expected to generate content about.
If the training data is unreliable, the AI will inevitably generalize from that noise and get the facts wrong, despite its best intentions. Hallucinating models act as grandiose confabulatories, creating extremely detailed fabrications about people and events with absolute conviction.
To behold how ChatGPT weaves complete, extremely detailed fabrications about my life. Fabrications, stories, narratives, which are utterly, irredeemably false, replete with names of people I have never even heard of, and with wrong dates and wrong places added to the mix to create.
It is terrifying to behold how a model creates the appearance of absolute authority while spewing irredeemably false narratives. The focus of stress testing has shifted from simple metrics to spotting deep vulnerabilities that could weaken a model's risk management capabilities.
Their focus has shifted. Rather than measuring the actual size of capital holes against a supervisory yardstick, stress tests now help us spot vulnerabilities in banks.
Regular transparency exercises are now a key tool to strengthen models against the storms they will face post-deployment. There is a growing skepticism that red teamers have enough imagination to really predict the chaos of a full-scale cognitive crisis.
There's a growing amount of skepticism that they can really measure what will happen in the next crisis. So Anat Admati is a professor at Stanford who's been arguing it's all garbage. You can't, these guys who are trying to predict what will happen to these companies in a financial crisis, they just don't have the imagination and understanding of how things work out in a panic, in a financial panic.
If the testers don't understand how a panic works in an information ecosystem, their stress tests will always underestimate the risk. Tech companies understood the commercial potential early on, leading many safety researchers to move from academic freedom to industry pressure.
Companies understood the amazing commercial potential of this nascent technology, and many of my colleagues moved from university to industry. I decided to stay in academia. I wanted AI to be developed for good. I worked on applications in medicine for medical diagnosis, climate to get better carbon capture. I had a dream.
When academia loses its experts to industry, the doctor for independent safety evaluation often gets replaced by a race for the next commercial toy. Most people only click on the first result provided by an AI, ignoring multiple perspectives in favor of the magical allure of a quick answer.
Everyone only clicks on that without looking at anything else. In this particular question, I asked, how can I price my business? And that first result is from the BDC, an extremely reputable source, but it's telling me how to price the business itself, not the services of my business. It didn't understand the query. Now on ChatGPT, if you type in, how should I price my business? It actually understands the query better. I don't know if you can read that up there, but it basically says, there are multiple ways to price your services.
This baseline of baseless advice becomes a systemic problem when the model lacks sources for its increasingly confident claims. In AI evaluation, we must look at where the stress is placed in a sequence of tokens to ensure the model is easily understood by safety protocols.
Put an image or a symbol in your mind, you can almost feel their meaning. And there's another category of words that are meaningless. They're grammar words, okay? So you need to understand this distinction. Let's look at meaning words first. So if I look at this sentence here, sleep is key to good health. You can see here below in the voice recognition software that sleep is key.
If the internal stress of a model's tokens targets the wrong logical unit, it fails the basic marking criteria for public safety. Red teaming involves looking at the internal structure of the model's processing to see if information is being partially or completely misrouted.
Black box testing, white box testing, grey box testing. In black box testing, internal structure will not be it won't be information about for testers. In white box testing, internal structure will be completely known. In grey box testing, internal structure partially known. In black box testing, there are two types of testing: system testing and user accepted testing. In white box testing, two types are also there: unit testing.
In black box testing, we don't see the internals, so we must rely on observing how the output deviates from the expected value. Just as in pronunciation, processing a logic chain correctly makes an immediate difference in how natural and safe an AI sounds.
Correctly will make a big difference to your English pronunciation. You'll immediately sound clearer and more natural when you speak English. Let's start by looking at sentence stress in more detail.
Look at a sentence. How about we go for a coffee this afternoon? In this sentence, there are two kinds of words.
If a model misses the stress words of truth, it sounds like a weird distortion that users should immediately recognize as a warning sign. We measure data errors in processing throughput versus the average. A model that stays to the right of the failure average is a model we can trust.
We see over here, the 7982 from Ruckus had this red line was way to the right of the average, meaning its red line is iPad video errors, far to the right. It stayed with fewer errors longer than average. And its blue line, its data, was above the average line. So in video performance, it was better than average. And in data throughput, performance is better than average.
High performance in a stressed test means staying below the error line even when pushing double the average amount of complexity. It's a big misconception that models act in a vacuum. They are often just passing on exactly what is required of them by their training environment.
You're out of line if you blame YouTube for that. YouTube is only passing on something that is required of them to do by... Now take note of this, it's important. The service, the YouTube system, web page, whatever you call it, whatever category it is. And I'll tell you something else too. If we take a little side trip off from that trip, is...
Safety evaluators must log these requirements in a logbook of truth to ensure we aren't blaming the model for its own flawed instructions. We employ active mitigation strategies by controlling parameters like temperature, which dictates the level of randomness in the output.
And what these are using some of the settings of the LLM, such as settings that control the parameters of how the LLM works during generation. A good example of that is the temperature parameter, which can control the randomness of the output. So a lower temperature will produce more conservative and focused responses, while a higher temperature will generate more diverse and creative ones. But the higher the temperature, the more opportunity for hallucination.
While high temperature creates creative results, it also creates the perfect environment for a model to take us on a journey millions of kilometers off target. Mitigating the risk of extinction from AI must be a global priority. And that starts with testifying before leaders about catastrophic systemic failures.
Statement goes, mitigating the risk of extinction from AI should be a global priority. I then testify in front of the US Senate about those risks. I travel the world to talk about it. I'm the most cited computer scientist in the world, and you'd think that people would heed my warnings. But when I share these concerns, I have the impression that people get this.
Evaluators carry a heavy responsibility to ensure these concerns are heard by the world's most cited scientists and policy leaders. Red teaming the model is the only way to avoid a future where human joy and critical thinking are replaced by efficient, hallucinated nonsense.